Hello, my name is Natalia, and I'm a software engineer at Zulka with a strong interest to security.
Hi, I'm Giovanni. I'm a principal consultant at Zulke, and I've got a strong interest in your data instead.
So, why are we here? Nowadays, we build extraordinary systems. We put a high effort in order to bring it from the design to production. We do a hard job to make it beautiful, robust, very speedy. However, we tend to forget a very important aspect: security. However, it brings us a high impact on our cost, on our reputation, legal impact, on our missed deadlines. And you may think it's just about the banks because they're always associated with the security. However, even small system can contain sensitive data. For example, a flower shop. What can possibly go wrong with a flower shop? But think if it was your data, your name, address, your phone number, your credit cards. I preferably don't want to be stalked by a stranger who just know my address. And it's not just about someone sitting at home trying to hack your assistant sitting in pyjama over the internet. Internal risks, internal threats are even more risky than external ones, because it can be upset colleague or someone interested to selling internal data. So you try to protect your system from bad guys, no matter where they are.
Yeah, and also looking at the keynotes earlier today, you know, when they talk about how cool Alexa is, or here we have the Google Assistant, or the Internet of Things, you know, the light bulbs, shower heads. All these technologies are very exciting, but you know, with new technologies, new excitement, usually there are new challenges. So at Zulka, actually, I've been working on some of this stuff. And imagine trying to manage your bank account with Alexa, telling Alexa to give you the balance, to make some payments, look at the credit card, and then somebody gets into your house and realizes that actually there is Alexa there and starts asking questions and maybe transferring money into his own account. Or light bulbs. A couple of years ago there was a denial of service attack on the internet launched by Internet of Things enabled light bulbs. Or the shower head. We actually have been working on some of these Internet of Things shower heads were installed in hospitals, where they do also control them from remote and do some kind of hot water flush to disinfect them. Now imagine a hacker that gets there and gives a hot water shower to somebody inside there. How nice would that be? Yeah, all this relates to the fact that, you know, the S in IoT, that stands for security. And also, the other thing about security is that usually when people talk about what they want out of the system, they generally don't tell you, I want it to be secure. It's something they actually expect, okay? So they won't ask you, make sure that my data is protected. They assume it will be protected. Okay, so you have to work towards that goal. And adding on that, there are also laws now. So the fact that security is becoming a strong concern, because basically the world is running on software. Now we have laws like the GDPR protecting your user or consumer data, okay, which come with big fines. So like GDPR or NIS regulation is also about cyber security in companies, so companies that have to protect themselves from cyber attacks. Not respecting these laws, there are big fines. So GDPR is up to 4% of the international gross income of your company, okay, which can be a lot, but there is also jail for the directors. But apart from also money and jail, the other aspects are also, imagine, society risks. Now they talk about the election hacks in the United States with or Brexit. We live in London, UK, where they are talking about the use of Facebook data for influencing the vote in the referendum. All these things have deep implications in society, so we really need to be careful about that. And in fact, as you can see now, even in the media, in the news, you'll see the Financial Times has a security section. So the register as a security section. So it's not something for the American movies and the programmers anymore. It's also something that the wider population is being concerned about.
So you may think it's not that often, those hacks. However, let me show you the biggest hacks only in this year. It's quite impressive numbers, especially those on top. And if you think that it is just big companies, let me show you the statistics of 2013. And since 2013, there was 3 billion records have stolen, which gives us 72 records have been stolen every second. This is quite impressive number. So, can security be really retrofitted? Well, you may think that, yeah, it is a concern, and at the end of the project, I will start thinking about the security, I will do maybe a penetration testing, and everything will be fine. However, not. It's not that easy, and sometimes it is hard to retrofit because some wrong steps can be made on the design phase, and it's actually very expensive. On the graph, you can see how expensive it can be later on the project, and you don't really want to be at the end. Because you really need to start from the beginning, because the security, it's not a feature, it's a system quality. So, how should we start? Don't aim for 100% security, because it's almost impossible. And system is already concerned to be secure when the cost of hacking the system is much higher than the value of the data that you can get. And it depends on the hacker, because if it is a professional hacker that really wants to use your data, he wants to do it fast, use your data and go on. However, if it's a student or someone really really interested to prove that he is awesome, he can spend like weeks or months and finally hack your system. So your goal to make a hacker being bored of hacking your system before he can achieve it. So start from early on. Earlier you start, cheaper it will be for you and less effort you will bring. So start from even writing user stories. On the level of the stories, you need already to think what can possibly go wrong. And the tool to do it is a threat modeling. Basically, threat modeling is a system analysis with a view of security. It's a risk assessment of your system. And you really want to introduce threat modeling with every story in your backlog.
Yeah, so for modeling threats, you probably want to know what a threat is. A threat in this context is a goal that an attacker can have. Okay, so if your system has credit card data, a threat could be, the goal of the attacker could be to actually steal that data. Yeah, that could be a threat. And then there is the concept of vulnerability. Vulnerability is actually a flaw in the system or a bug that will allow the attacker to get in your system without any rights to do so and will be exploited to achieve the goal. Okay. So when you do threat modeling, what you are trying to do is to model these threats and to understand how to protect your system.
So when you start doing it, think about how your system is built. What data you have, what components are, how they interact, what is the data flow of the system.
Yeah, so in terms of when you're modeling the system, you have to think in terms of entry points, trust levels, assets, trust boundaries, which means entry points is all the ways you can actually interact with your system. Could be a REST API call, could be a configuration file, could be an open port to a database or one of your servers that will allow you to get in, could be anything that will allow you to do something, influence your system. Trust levels is about how you deal with authentication authorization. If you don't deal with that, you are not secure by definition, so you can stop here. But in general, it's how you authenticate people or other systems to interact with yours, and how you authorize them to perform some operations. The assets are the things you protect. Assets could be more concrete, like credit card data, addresses, phone numbers, things like this, but could be also something else. Could be also the fact that the system has to be available. Yeah. So, for example, imagine a situation where a hostile country will try to attack your country, and one of the things they do is denial of service attack on the systems of the emergency services, the ambulance, things like this. So basically, people are suffering somewhere and they cannot be actually helped because the ambulance cannot be notified. Yeah, a denial of service attack. And also, when you talk about these things, there are the trust boundaries. So what this means? So if you look at the picture there, imagine all these circles and the square like subsystem of your system. Imagine also could be your microservices architecture. Okay, the red lines are the trust boundaries, which means when you access services from the reader, you are within the reader trust boundary. But when the reader tries to access the controller there to perform its own services, okay, goes within the trust boundary of the controller, which means they have to have some agreement on how they handle authentication authorization. If you are not careful in designing how the systems interact, you may end up in a situation where you can give some users more permissions or rights than what they should have. Okay, so you have to reason in these terms there. Okay.
So you try to protect your assets, and probably what you want to know is what the type of attack can happen with the asset, and there is a help of classification of attack. We're going to use the Stride because it is one of the most popular one. However, you can use any classification that you would like. So Stride, what it is, it stands for spoofing. Basically, it is when the attacker is misrepresent himself and listening to your data. So it's basically a man-in-the-middle attack. And sometimes in the news there was like a GPS Russian spoofing. So here it is. Tampering. Tampering basically is a changing of the data to influence, for example, election.
Election fraud, for example, is the typical one.
When the data is changed, so the result of the election is completely different.
Yes.
Repudiation. It is basically the denial of truth when the person, for example, in the bank, tried to transfer money and then say like, this is not me, I haven't done it. So you can prove that it was his action. It's basically the elimination of the user error, basically.
Yeah, could be user error, or could be somebody that tried to be malicious in some ways but wasn't really prepared well as an attacker. But then also there is information disclosure, confidentiality. This is what most people think about hacking, isn't it? So stealing data they shouldn't have access to. There is denial of service, so availability, the fact that the system is actually working correctly and serving the users. And also there is the elevation of privilege, authorization. This is the stereotypical hack from the movies where somebody enters in a system, gains root access, and then can dominate the company. Okay. So this is a classification that is quite useful when you want to actually model your threat, so you know what you are dealing with.
So you basically need to stand in the shoes of the hacker and think what can possibly go wrong and represent how can be achieved. So one useful tool for that is an attack tree, which is shown in the example, where the root is basically the goal of the attack, and then all children are how it can be achieved, so all basically the ways how the attack can be fulfilled. In the example, there is an OR tree, so any of the children of the root can bring to service being down.
Yeah, basically, if you get root access, you can actually bring the service down. This means so you don't need to also have internet access down or anything like this. Yeah, but also when you say, let's say you model, you have all the classifications of your threats. You have your attack tree. You have all. Your entry points, all this data. So how do you make sense of it? Because all this is information that you should use to design your system in a secure manner. So what you do, you basically document it. There aren't any prescribed formats to do this. You can have a thick Word document, or you can use tools like this from Microsoft, which is a freely available one. But basically you need to document it to understand the threats you are dealing with. Doesn't even mean that you have to have a thick document. If you work in an agile manner, for example, something you can do is when you write user stories, you can come up with attack trees for the security aspects of those stories. You can document also the entry points affected by that. You can put that as part of the story and use that when you implement your functionality. Of course, you have to relate that also to the architecture of the overall system. So you cannot focus on a specific requirement only because, remember, is a system-wide concern. Okay.
And when you collect the data, when you start thinking what possibly can go wrong, you may start implementing every possible security in your system. However, you really need to think about the strategy, how you're going to do, what to do first. And one of the good approaches is to start from low effort and high impact. This is basically small things that you can do, like encrypting the communication, encrypting of your data. And it will really improve your system. And then probably you will start thinking about something taking more effort that still brings high value. For example, penetration testing. When ethical hacker really tries to get into your system and find the potential weaknesses and how to get into your system, which requires more skills, quite a lot of money, but still brings you high impact. And then you may or may not introduce some small changes which will bring you lower impact as well. For example, if your data is already encrypted, hashed, and you want to add salt or extra level of hashing. And don't do high effort and low impact. It just doesn't worth your time and money unless there is a specific requirement from the government or legal requirement. When it doesn't bring you much of the value, but you kind of have to do this, otherwise big fines.
Yeah.
And sometimes it's not static. For example, when you have a feature that is used not by many people, so the probability of the attack happening or revealing the vulnerability is quite low. And then it is exposed to more users, the probability is rising. So 3 can become 1, and you really need to implement it because it's a high impact. So start from low effort and high impact. And what does it mean? It means do some small things like encryption of the communication. No matter what you're using, encrypt it. Hashing of the passwords. You really need to hash your passwords and don't have it in a clear text. There is just no words more to say. And apart from passwords, you may want to encrypt other data. For example, don't rely on the not stealing the database, because if someone has stolen your database and it has clear text credit card numbers, there is no sense to encrypt the password either.
Yeah, and also this is a typical problem. I mean, we've seen this also in a system, in an authentication system. Don't log security sensitive information. So when you write the logs with the warn, info, bugs, stuff like this, okay, usually developers do that for testing purposes, but let's not go there because I'll start a rant otherwise. It's like, don't put sensitive information there because those logs are actually not secured. You know, they are accessible by far too many people in the company. Yeah, the fact that there is a webmaster doesn't mean that the webmaster has the right to see sensitive data in the database. Okay, so no passwords, nothing sensitive. The only exception, which is not really an exception, is when you want non-repudiation. When you want to address non-repudiation, you need to log what happens to the system somehow, but those are different kinds of logs. You have to do them, you have to manage them in a secure manner, okay? You have to protect them in some secure areas and limiting access, because that is a completely different thing, okay? And the other one that for some reason happens, and we don't think about this, is don't put your production credentials in your Git repository, okay? Now, this should be obvious, but it isn't too many. Your Git repository is another entry point to your system. Okay, and the thing is, even if it is private to your company, usually these repositories are accessible by everybody in the company as well, which means if you put production information or sensitive data there, anybody, a bad colleague can see that and use to hack the system. Okay, to manage secrets, use secret management tools. So if you do this to because otherwise you don't have them in Jenkins for your CI pipeline. Well, the credentials in Jenkins are not perfect, but are much better option. Or Ansible Vault, or some kind of secret management tools. Okay. And last but not least, one of the favorites of the internet is validating inputs. Somehow, after all these years, there are still programmers that don't write input validation. This is easy to do. You know what you're expecting. Do that, because otherwise you can really expose some incredibly bad security holes. In the joke here is basically this letter says, the name of the son is Robert, bracket, semicolon, drop table students, semicolon, minus, minus, and basically ends up deleting the database of the school. Yeah. So it should be an obvious one, but still is worth repeating.
So if you are using REST, I hope you're already doing HTTPS. If no, let me introduce you a Pineapple. So Pineapple is a tool on the left that looks like a router and acts like a router serving you internet through another source and scanning your SSIDs in the laptop. So when you have previously connected and trusted to the SSID, your laptop will automatically connect to it. And when you connect it to like mocked SSID, you go through the Pineapple and it can have all your data that is not encrypted. And please don't use self-signed certificates, just because such tools like Pineapple can still serve you self-signed certificates. And if you're a person who just like click, accept this certificate just because it's super annoying, I don't want to see it, you're pwned. And there is no difference between HTTP and HTTPS. And in testing as well, use certificates, valid certificates, just because you really need to know in advance how your certificate management going to look like, how you're going to do it in production, who has access to it, how it's going to be done, when are you rotating them, because when it comes to the production, you don't really want, and one day all your microservices have expired certificates and then manually have to go into production, change all of them. You really need to think about it much in advance.
I can add to this that doing this manually is uncomfortable, but it also introduces other security risks as well.
Yeah. And it doesn't have to be expensive. If it's really a concern for you, use Let's Encrypt. It is a company who provides you certificates signed by a certificate authority. It's very easy and it is free. It gives you a certificate for 3 months only, however, it has tools for automating it. So there is no excuse not to use it.
And let's see, now sometimes we encounter developers that say, we use HTTP in test because it's faster, encrypting will go slow, and things like this. Typical performance-related opinions that are unsubstantiated, should I say, because this, if you go on this page, you see they run this test with HTTP, HTTPS, and actually HTTPS is almost 9 times faster than HTTP, which is not surprising because it's not simply HTTP with an S at the end, it's just a completely different protocol. So in terms of thinking, encrypting will be slower, will slow down my test. Actually, in this case, you'll gain speed and you'll have a better system as well. And one thing, if you have services with REST calls, and which is very common nowadays, be careful with GET requests because some web servers actually cache the URL in clear text in their logs. Okay, which means that if you put any sensitive data in the URL, it may end up in some logs, basically in the wrong place, where people that are not authorized can see that. One thing that I should say, because I've been recently surprised by that, is sometimes developers are confused from the fact that when you send a HTTPS request, the URL is not in clear text. Everything is encrypted, also the URL. So the problem are the logs. What is not encrypted and is clear text is the server name and the port, because if you encrypt those, the computer will not know who to call with your code, okay? Everything else is encrypted. So,
and it's not about just about the software that you're writing, it's about the environment that you're developing in. Because you sometimes don't know who has an access to your laptop, who stands behind. For example, we have a security expert who really trusted us, and after coming back from the coffee break, he found out that no matter what he is looking in the internet, it's going to be Nicolas Cage. And it's not just about the harmless plugin. Sometimes when you're using in big organizations like banks, where we had been working in the previous project, there are so many people that you don't really know who is around, who sits next to you. It can be a developer from another team, it can be a manager, or it can be someone sneaky who got behind authorized person.
Yeah. And then the other aspect is to think about the surrounding system. So how you deploy the system in production. So basically, if you have a continuous delivery pipeline or any other ways, like what steps do you follow to deploy this thing so you can handle the secrets in a reasonable manner? You don't have to expose them via Git or in an insecure manner. So you have to think about that as well. And where do you deploy it? Is it the system going to be deployed in a locked room with limited access? Is going to be deployed in a publicly accessible computer? And all these aspects, because all these things will actually help you design a more secure system for what it's supposed to do. How will your software be used? Yeah, so it's not about simply the code. It's like there is a reason why when you write the password on your computer, you cannot actually read it, okay? Because somebody could be working behind you and can steal it. So it's the same thing. Think about, I don't know, a banking mobile app where in your smartphone you do your banking, you transfer some money, then you close the app but doesn't log off the bank. And then somebody steals your phone or just finds it unlocked and has a look and opens the app and then has access to your bank account. So you see, it's not simply the software you write, it's also the context of use and the wider system where the software will be used and the actions of the users as well. So
is the threat modeling actually good? Well, yes, because you step into the shoes of the hacker and you see look at your system from the security perspective. And you start from early on, so it will help you to make a right decision earlier. Are there any disadvantages? Yes, because you can miss some threats, because we're all humans, it can happen. And the second, that the threat modeling is not granting you a good software by their own. And if you do like software in a clear, it is simple, the risk of the hacking is much lower.
Yeah, this actually ties with some of the principles in the keynote today from John Romero. So if you keep your software simple, it's not simply more maintainable, it's probably easier to make it secure as well. Okay, hackers find holes in complexity generally. And then make it part of your development activities. So start from the very beginning.
Start from very beginning. Start from writing. Start from thinking on the writing of user stories, which we mentioned before. Make it a part of your development, making it a habit, and you can put it as a definition of done. So you are not going to miss it. So you are not going to finish the story before you think about the security and analyze it. And software itself can have vulnerabilities, because threat modeling, it's good. You're thinking about the possible attacks from the hacker perspective. However, implementation of the system can as well have bugs, which is extra entry point into your system. And try to catch bugs as early as possible in your development before something else is built on top, because it's much harder to go back in it. And one of the life hack is to have a security champion. And security champion is not a person who is really specialized in security. It doesn't have to no security at all, but it is a person who is always raising the question of security in your team, who is always pointing, because when it's not your habit yet to think about the security, it's quite easy to forget. And what about starting and being your own security champion? So you may think that it is boring. Think about the code analysis, spend time on it because it's very time consuming, and we're all developers, so we really want to automate everything we possibly can, so automate it. Because there are really a lot of tools for that, and lots of them are for free, and they are covering quite a lot of aspects of your system, being it a website or a Docker container. And one of life hack as well to put it into your pipeline and make it execute on the each push and on each basically push into your CI, because lots of them have APIs or plugins that you can implement into your pipeline development. Sorry.
Okay. So also you have to be careful, because obviously when you are implementing something, you have to think about the libraries depend on the frameworks. They may have vulnerabilities, and also sometimes these dependencies may have dependencies on other libraries that have vulnerabilities, which means they still may affect you. Okay, so you have to be careful there. There is help. There are some websites that you can check when there is public available information about known vulnerabilities of various frameworks. An important recommendation is do not implement security libraries yourself. The mathematics behind it can be extremely complicated, and subtle errors in implementation can actually open big holes in security. So it's much better to use trusted libraries that are widely available nowadays. Okay. The same thing can be said with Docker. If you use Docker, if you look in Docker Hub, in the various Docker images there, if you go in the tags, actually they tell you what are the known vulnerabilities for those particular images. I think they run a daily scan on the things they have there, which basically allow you to decide if you are if your system is exposed to that vulnerability or not. It's a kind of informed consent. Okay, so it's not about scaring you off. I say these are some vulnerabilities. You know which ones are the known ones, and you may take a decision there. Yeah.
So, what should I do, Giovanni, to retrofit security in my project?
You should. If you do this, you haven't been listening, have you? So.
Yeah, but if it is a brownfield project?
Well, I know that. So at Zulk as well, our company, we often end up working brownfield projects. So we unfortunately get into this situation. Well, the very first thing you can do is actually using reporting tools like SonarQube, one of the ones listed before, that if you plug them in your continuous integration system, will scan your code and tell you what vulnerabilities are there. Okay, so it won't tell you everything, but at least it's a starting point. And then you can basically prioritize the risks and put the bugs in stories and deal with the critical risks first. Don't try to, again, same message as before, don't try to do everything at once. Some risks might even be accepted. You don't really want to bother with them, yeah?
And then once you fix the bug, you can write a test for it and make it a part of your integration testing. So you are catching it if at some point it will come back. And then you can tune your tools, and you can find less critical ones. You again prioritize it, fix it, write test, and do it in iterations. And as a complement to threat modeling, you can use a penetration testing. And it's quite often confused with vulnerability checking. But it is not, because vulnerability check can be done by anyone in this room by using those tools that we have been mentioning before. So penetration testing is, you really need certain skills for that. You really need to be certified, basically, for that.
Yeah, and I think we need to go a bit quick because we have only 5 minutes, I've been told.
Sure.
So penetration testing actually has a goal. So the penetration tester wants to hack into your system and, well, in this case, not wreak havoc with it, but actually find is ethical hacking that is to find vulnerabilities. Okay, so you can see what is there that can expose your system to bad people. Okay.
So summing up, don't aim for 100% security because it's almost impossible. And as we said before, system is already secure if the cost of hacking the system is much higher than the value of the data that the hacker can get. And think about the potential risks in advance, step into the shoes of the hacker and think what can possibly be interesting and possibly can be wrong with the system. And thinking about the security is not gonna catch you all the bugs of secure bugs that existing. However, thinking about it will bring you in a much better position.
Yeah, and as we said before, start from where you can have big gains. So from low effort, high impact, then you go to high effort, high impact, like penetration testing. Low effort, low impact, you may ignore them, maybe do them if you have time. And as we said before, with scaling of the system or the situation changing, some of the low effort, low impact can become high impact, low effort. So at that point, you might need to implement them. Don't go into high effort, low impact because there is nothing to gain there.
So to be more secure, make it a part of your development, make it a habit to think about the security. And start from the beginning because security is a system quality, it's not a feature, it's basically a non-functional requirement if you want. And think about the security as a whole, because it's not just about the software that you're writing. It's about the environment, it's about how you deploy the system, how the system is going to be used, and so on. Yeah, so it's not just about the software. Think about the security from the beginning and make the life of hackers harder. Thank you.
Thank you.
Questions?
I think we have no time for questions. You have some time for questions?
Yeah.
How much have we got? So we've got 5 minutes for questions if you have any.
Please raise your hands. Okay.
Yes.
This one? Okay. Ask the question, we should be able to hear you.
Okay. So you mentioned before that you can implement tests to reproduce the bugs and before you fix them so that you will not bring them back into your code. But I think many of the security issues or inside the dependencies are not that easy to be shown in your code. So how would you approach that? You will start with a fix and then work backwards from there and then add the tests later, or would you try to add the tests so that you are sure that you are fixing something?
Now you have I can answer that.
Yeah,
so
sure.
To decide that you have fixed the issue, you have to have a test there, because otherwise you don't know that you have fixed it. Okay, and remember that if you do that as a manual test only, then you have to do the manual test every time you release the thing to avoid regression. So in general terms, if you find the issue, there are a set of steps that expose it. So basically testing it means automate that set of steps so you can reproduce it. In fact, when you do also penetration testing, there is some penetration testers do that in a structured manner so they can tell you exactly what they've done, so you have a better chance at reproducing it automatically. And then of course the fact that it is easy or difficult depends very much on your system. So if you are retrofitting security, it might be that to actually fix that and test that, you have to do a big effort in redesigning a chunk of the system. If you have done things in a better way from the very beginning, chances are you will have much less work than what you think.
Okay, thank you.
Any other?
Is there any other question? Okay.
Okay. For what concern availability of the system, in particular the attack that reduce the availability of the system, which is the trade-off between security and availability? For example, I'm from Alstom, so railway system is not possible in general to stop every train due to cybersecurity attack. So which is the trade-off between the two aspects?
Well, yeah, I think it as well depends on the system.
So I don't think availability is actually is an aspect of security. Depends on the system, as Natalia says. So let's say that you have a denial of service attack on a system that is used to control drones that are used to bomb people. Okay, so you can have at that point, what happens is you have a drone in the air that goes wild because nobody can control it, and that can wreak havoc in strange ways. Or denial of service attacks that will make unavailable the emergency services, like the ambulance, things like this. All these things can be exploited. They can be the effect can be as bad as an attack with bombs and missiles. You see, so of course depends on the system. Yeah, if it is the flower shop down the road that they have some electronic system to handle their customers, a denial of service attack there probably is not really a gigantic concern. Okay, but in other systems could be really an enormous security risk. Yeah, think the denial of service attack to the Amazon cloud system, which actually happened some time ago. Yeah, with all the companies that rely on that. So you have to think in this time.
I think availability is as you said, as a security concern, because if there is an attack that makes the system unavailable, it's like a security problem. So I don't think that there is a trade-off between them. It's supposed to be thought as a part.
Okay, thanks.